I'm Ross Bagurtis, and I'll be your instructor for this video that you're watching called Introduction to Data Networking. Now, what I hope to accomplish in this video is to show you that you actually know more about your data network than you think you do. And what I want to do is introduce to you the components of a data network by examining a very common home network setup. So let's dive right in and take a look. Now, really what we want to do here is get you as a student prepared to understand the material of the Cisco Certified Network Associate certification process. And there's a lot of terminology that we need to know, and in order to accomplish that best, we really need to have a frame of reference. So what we're going to spend doing here is really building your vocabulary, and we're going to start to segregate topics into very specific pieces so we can break them apart, analyze them, and then use that to later on build an entire data network and have a great understanding of how CCNA topics fit together. So what I have up on the screen here is a typical home network setup. And what you see is a couple devices on the internal network. I've drawn a wireless laptop. You may nowadays especially have either a tablet like an iPad or an Android tablet like a Samsung device. You may have a smartphone like an Android or iPhone that you have connected to the wireless network, but ultimately this laptop represents any wireless device that we would have in our network. We also have a wired PC drawn in here. That wired PC has a wire, a cable connected to it that goes to some device. Typically, what we do in a home network is we have some type of wireless router. Sometimes we call this our cable modem router or a wireless access point. My mother called it my favorite Martian because it had two antennas on it. So depending upon where you are and your level of technical expertise, you may see different names for this device, but ultimately it's going to be a device that sends out a wireless signal to your wireless devices, and that device will also have connections so you can plug wires into it and connect devices like that. Now, typically, this cable modem router, wireless router, my favorite Martian, whatever you're calling it, typically that device is also connected to some type of cable modem or DSL modem device that actually connects you to the internet. Now, this cable modem device is usually provided by your internet service provider. Sometimes this cable modem device here is built into the wireless router. So sometimes these two devices are the same, sometimes they're separate. But ultimately, this is a very basic setup of a home network. Couple devices, wireless router, cable modem that connects us out to the public internet. Well, this is great, and these are very clean descriptions of the physical devices. However, in order to understand data networking, we need to take a little bit of a deeper dive. This may be a drawing that you get when you open up the package of your wireless router with instructions of how to set it up. It's going to have very basic drawings, basic diagrams, but it's not going to have a lot of content. And in order to get CCNA certified, you will need to understand all of the nitpicky, hardcore details of data networking. So let's start. Let's take a look. We're going to add some IP addresses onto this now. Now, the IP address is the logical identifier for the device. Now, that is jargon right now. A logical identifier for the device. What the heck does that mean? Well, a logical identifier, we have something that we use every day that we know of that's a logical identifier for buildings, and that is the street address. As a matter of fact, the street address of your home or business in combination with the zip code looks very similar to what we use in data networking to logically address devices. So here in our home network setup, we're going to use IP addresses just like we do on the entire internet. And the IP address, just like the post office system, has a portion of it called the network portion. And the network portion is kind of like a zip code. It represents a whole bunch of addresses inside of a certain area. The second part of the address is called the host portion. Now, the host portion of an IP address represents an individual device on a data network. Same thing with the post office. We have zip code identifying an area of buildings, and then we have an individual house number and street address that identifies our building uniquely. We may add an apartment number onto that number as well to identify our specific living space inside of a building uniquely as well. But it's really not all that much different than IP addresses. IP addresses have a network portion and a host portion. In the physical world, the post office has a zip code and street address. Let's take a look at this. If we look on the leftmost side of our wireless router, what we're going to notice is that the IP address that I have set up here starts with the same three numbers, 192.168.10. And they all start with 192.168.10. If we look on the other side of the router, the IP address starts with 203.0.113. What we can understand from this is that because the first part of the address is different here, we know that they're on different networks. Now in future videos, when we learn subnetting, we're actually going to learn all of the details about how to separate out the network and host portion from these addresses. But as just a place to begin here, we can clearly notice that the first three numbers of the address on the left side of the router are different than the first three numbers on the right side of the router. And this means that they're on different networks or in different zip codes. And the whole purpose of the router is actually to translate and pass traffic from one network or zip code to another network or zip code. So its job is to act as kind of the post office here in passing these packets between the two networks from our internal network here to the external network. You'll notice that on the left side of the network that even though the first three numbers are the same, the last number is different. Here we have 100 for our wireless laptop, 105 for our wired PC, and .1 for our router. Well, that's because these three devices all belong to the same network, and there are different hosts inside of that network. All these devices can communicate with each other. This is going to become extremely important later on when we learn how and when devices can talk to one another and what type of network equipment we need in order to move the packets from one network to another. Let's add some complexity to this. So our devices not only have this logical address called an IP address, they also have a physical address called a MAC address. Now that MAC address is a unique identifier, and that unique identifier is actually burned onto the network interface card of the device we're using. Now our laptop over here has this MAC address, which is its physical address that I've listed right below the IP address. The wired PC has a different MAC address. The numbers aren't even lining up very well. Our wireless router, actually every interface on our wireless router that can have an IP address can also have a MAC address. So any place we have a MAC address, we can assign an IP address to it. And any place we have an IP address, there's automatically a MAC address associated directly with that IP address. You can see on the other side of our router, we also have another MAC address here associated with our public IP address. Now, the public IP address on this external interface here is only in reference to the internet. We have the public side of our network or the global side of our network, which is the internet. And then we have our private side of our network, which is local. So we have local, private, and public global. Now, the best way I think about these MAC addresses is kind of like a social security number. In the United States, at least, when we're born, shortly after we're born, we are issued a tax ID number, and that tax ID number sticks with us for life. So we kind of, at birth in the United States, we are burned in with this 9-digit number that represents our tax identification number, so we can later pay taxes in this country. I suspect other countries have very similar unique identifiers for every single person in the country so that they can pay their taxes and do other things. And in the same way, this correlates directly with the MAC address. Because me as a person, Ross Bagurtis, I have my own social security number. And that social security number has stuck with me for all of my years of life. However, I have moved around to probably 20 or 30 different homes throughout my lifetime, And because I've moved to so many different homes, every time I move to a different house, that house has a different address and zip code. Because it has a different address and zip code, I then associate my name and social security number with the street address and zip code of my house. So the two are associated together. So that when I pay my taxes, or if the federal government owes me a refund, which I always hope is the case, the government now knows that my social security number is associated directly with a real address, and then they can create a check and mail me the check through the post office using the logical address of my house that I currently live in. So this physical address, this MAC address, is very much like our social security number. It sticks with the device, and we can take the device wherever we want. So in the case of our laptop over here, our laptop we can move from network to network to network. We can use it at home, and then we pick it up and we take it to work, and we use it at work. And then we go to the coffee shop, and we sit at the coffee shop and open it up and connect to the wireless and use it there. What's going to happen is this physical address here will always remain the same no matter what building I'm in, no matter what network I'm connected to. This MAC address will remain constant. However, this IP address will change or could change from network to network to network that I belong to. So I could be on a different network at home versus work versus the coffee shop. So my logical address is going to change based on the network that I'm on. So my IP address will change based on the network I'm on. My MAC address is going to stay the same no matter where I'm at. Now, does that mean I can't change my MAC address? No, we actually have some techniques that hackers and network troubleshooters can use to actually change the MAC address on their device and either troubleshoot problems or cause nefarious activity. We typically do not change the MAC address unless we absolutely need to. So this is truly the basic introduction to a data network. What we're going to see happen is we're going to see devices use this MAC address to communicate from one device to another device on the local area network. So on our inside network here, the inside local network, these three devices, the router, the laptop, and the PC, they can all communicate with each other very easily. They're all connected to the same data network, and they can send traffic between each other very easily. When these devices now want to connect out to the internet, so let's say we want this wired PC down here to connect out to the public internet and reach trainsignal.com. Well, in order to do that, TrainSignal's out here on the public internet. It has a different IP address, so it's on a different network. So what we have to do actually is send our traffic from the PC over our local network to the router. Then the router will make modifications to the data, not just the data, but the envelopes, the electronic envelopes that we carry the data in. The wireless router will make changes to that and then send that traffic out to the public internet. The internet will respond and send the traffic back to your workstation, and then your workstation will display the trainsignal.com website. This is a very brief introduction to what we're going to be talking about in future videos. For the rest of the CCNA content that you'll be examining, we're going to take these concepts and keep building upon them until we have a solid understanding of how data networks work, so you have a very clear understanding of the topics in the CCNA exam. This concludes Introduction to Data Networks.